The final part of our look at redox is the electrolysis of aqueous solutions. Don't forget these points that reduction occurs at the cathode and oxidation at the anode. You can see here I've got my electroplating reaction. It's a time lapse of over 2 hours. I apply some power to this, and you can see on the right hand side there the copper seemed to grow off the scupula. Alright, so determine the products at each electrode when a dilute solution of sodium chloride is subject to electrolysis. So electrolysis would be an electrolytic cell. I would have an anode and a cathode as determined by the placement of the power supply. And I would use 2 inert electrodes for something like this. So the dilute sodium chloride solution would contain water molecules, sodium ions, and chloride ions. All right, and both water can be attracted to both cathode and the anode, while the sodium would be attracted to the cathode and the chloride ions to the anode. All right, we're going to look at the possible oxidations and possible reductions that can occur in this system. All right, so water could be oxidized to oxygen gas and hydrogen gas. This would have a cell potential of negative 1.23 volts. All right, you'll notice if you look in the data booklet that this is listed as positive 1.23. I've reversed the reaction and therefore reversed the sign of this already for you. Likewise with the chloride to chlorine half reaction, I've reversed the sign from what's in the data booklet because I've reversed the reaction. So the oxidation would have a potential of negative 1.36 volts. The possible reductions that we can examine would be the reduction of sodium ion with the addition of an electron to sodium metal. This has a cell potential of negative 1.27 volts, while the reduction of water to hydrogen and hydroxide has a cell potential, as we'll see here, I'll squeeze it on the screen, of negative 0.83 volts. All right, so what we need to do now is we need to determine which of the 4 possible cells we could form has the least negative cell potential. All right, you could say most positive, but they're all going to be negative because we're forming electrolytic cells. All right, these reactions don't occur spontaneously. So the least negative E0 cell will proceed. All right, this being that we're going to supply an overvoltage, so we're going to supply more than enough electricity to make any of these reactions occur. But what's going to happen is the reaction that will occur the most readily or the easiest is the one that essentially has the least negative cell potential. It's going to be the one that's met first. So I'm going to make the 4 possible combinations here on the screen. I've labeled my reactions 1, 2, 3, and 4. So if I make a full cell out of reactions 1 and 3, all right, I use my equation oxidation plus reduction, I would get a cell potential of negative 3.94 volts. When I combine the oxidation of water with the reduction of water, I combine them and I get a cell potential, of negative 2.06 volts. All right, I'm just going to move to the other side of the screen here so I have some room. When I combine the oxidation of chloride with the reduction of sodium, I come away with a cell potential of negative 4.07 volts. And when I combine the oxidation of chloride with the reduction of water, I come away with a cell potential of negative 2.19 volts. All right, so it is important that if given an aqueous solution, you actually do run through all the 4 possible half cells that could be made, because the water oxidation and reductions are always going to be possible. And we see in this case that actually the reaction of water at both the anode and cathode is the one that is going to be favored. All right, so I'm going to see the oxidation of water and the reduction of water. All right, I should see bubbles appearing at both electrodes. All right, I should actually be able to quantify this, that stoichiometrically I should be able to see twice the number of bubbles of hydrogen as I do oxygen. All right, you can work out the actual overall balanced reaction there for this one. All right, but it would be important to talk about what would be observed at each of the electrodes. Now, what is also going to be important is that there are some finer points to some specific examples that IB would like you to know. We'll look at those in a subsequent video, one of them being what the difference between a dilute sodium chloride solution is and what a concentrated sodium chloride solution is. And if the solution is concentrated, a different reaction occurs even though the math here on the screen about cell potentials would all be the same. All right, we'll have a look at that next.